Koti Surya Samaprabha, Nirvignam Kurume Deva, Sarvakareshu Sarvada. Namaskar and a very good morning to the distinguished ladies and gentlemen of this august house. It is a matter of great privilege and honor for me to be a part of this National Conference on Mathematics Education and share my space with this learned gathering in the field of mathematics. I, on behalf of Northeast Regional Institute of Education, NCERT Union, and the entire team of organizing committee of this National Conference on Mathematics Education of NCERT, welcome you to this 3-day National Conference on Mathematics Education. Friends, as I have just announced that the chief guest for today is Sri Rakham A. Sangma, Education Minister, Government of Meghalaya. He is with us this morning as the chief guest. May I request our principal, Professor F.G. Dakhar, to kindly escort the chief guest of today's function to the dais. I also request Madam Brajanti Devi, Head DESN, NERIE, and convener of the National Conference on Mathematics Education, to kindly escort Professor G. Ravindra, former director, NCERT, and the visiting professor of the Christ University currently, and Professor Anup Rajput, professor in mathematics from NCERT, to be on the dais. Please take your seat, sir. Thank you so much. As it is customary to begin the sessions with the lighting of the lamp, for this I would like to invite all our esteemed dignitaries on the dais to kindly light the lamp and begin today's session, inaugural session. As we light the lamp, we pray to the Almighty for blessings with all humility. Give us wisdom to make this world a better place. May all human beings live in harmony with nature and other forms of life. May the truth prevail. May the darkness of ignorance be swept away by the dawn of self-realization. Thank you all. May I now request our principal, Professor F.G. Dakhar, to extend a warm welcome to the august gathering. Madam, please.
Thank you, Dr. Tulika D., one of the conveners of this National Conference on Mathematics Education. Honorable Shri R.A. Sangma, Professor G. Ravindra, Professor Manjul Bhargav, who is joining us online, Professor Anup Rajput, Dr. B. Devi, members of the advisory board, Professor Chaurasia, Dr. A. K. Garg, Dr. Arup Kumar Saha, Dr. B. Madhu, Dr. Patanjali Sharma, and Dr. A. Thomas, and to all the delegates, ladies and gentlemen. On behalf of the faculty, the administrative officers, staff, and the students of the Northeast Regional Institute of Education, a constituent unit of the NCERT, New Delhi. I stand here to welcome each one of you with poinsettia plants and Christmas hollies, for this is the time that you will find these flowers commonly available in our city, Shillong, and in some of the districts in the state of Meghalaya. Dr. D.P. Saklani, our respected director, Professor S. Srivastava, our joint director, NCERT, Professor S.V. Sharma, RIE, Principal RIE Ajmer, Professor Mandal, Principal of RIE Bhopal, Professor Agarwal, Principal of RIE Bhubaneswar, and Professor Shrikant, Principal of RIE Mysore. Together, they join me to welcome you to this national conference. Yes, it is not possible for them to be here, but they have sent their greetings and they have sent their messages in this conference abstract. And I request each one of you to spare some time to read the messages which are being sent by our very senior and authorities of the NCERT. Thank you. We have here on the dais Shri Rakam A. Sangma. He is the Honorable Minister of the Department of Education, Government of Meghalaya. I extend a very warm welcome to you, sir, and I thank you for being here amidst your busy schedule. Ladies and gentlemen, within a span of 5 months, this is the second time that the Education Minister is visiting the Institute. Can we give a big round of applause for that? This shows your interest, your concern in school education and in teacher education. And so, as the Institute, which is here in the Northeast and which is based here in Shillong, in your capital, in your state, Meghalaya, we hope that we will continue to work together for the upliftment of education, both in school education and in teacher education. To our dear Professor G. Ravindra, our former director, NCERT, I am extremely happy, and I know that my colleagues and those who have worked under you, they are also very happy to see you here with us. Thank you, sir, for the bond that you still have with the NCERT and with all of us, because you are our leading light. And thank you for taking the pains to come all the way from Bangalore to be with us. Please give sir a round of applause. And I know that we will be enriched by the deliberations and from the speech which we will be hearing from sir. We also have with us a very renowned personality, not only in our country, India, but even throughout the world, who is joining us online at this time. And he is none other than Professor Manjul Bhargava. Professor Manjul Bhargava, though initially he wanted to be here in person, but because it is not possible for him to be here, he will be joining us. He is joining us online, and he is the keynote speaker for this national conference. Professor Manjul Bhargava is a professor in mathematics, Princeton University, New Jersey, USA. Some of you may be wondering, a professor in mathematics, Princeton University, New Jersey, USA. The reason is because Currently, he is the chairperson and the mentor of the National Syllabus and Textbook Committee, Government of India. He is really on a very, very tight schedule, being the chairperson and the mentor of all the curricular groups, but yet he will spare his time and he will be there to give us the inaugural address. Professor Manjul Bhargava, I therefore extend a very, very warm welcome to you and a big thank you for accepting our invitation. A word of welcome, as I mentioned earlier, also goes to all the advisory members of this national conference. Ladies and gentlemen, you must be knowing that this national conference, it is being designed by the NCERT. And every year, the constituent units, the regional institutes, they take their turn in hosting this national conference. And this year, it is here in our Northeast Regional Institute of Education, Shillong. I therefore thank each one of them. Some of them arrived yesterday, some of them today. Thank you very much. I mentioned your names, and together they did see to the final touch-ups on what actually will happen on these 3 days. Thank you so very much. You will agree with me that this conference will not be possible had it not been to all the delegates who are here present and who are joining us online. It will not be possible. So therefore, I request all the paper presenters, if you can kindly stand, we want to give you a big round of applause for coming from all parts of the country and to be here with us. Thank you so much. And please be seated. And amidst the delegates, we also have our students from RIE Bhopal, please can you stand, RIE Mysore, and we also have our students from the Northeast Regional Institute of Education as paper presenters. I am so encouraged, please be seated, to have budding mathematicians, budding teachers who are interested in mathematics education. So with this, I welcome each one of you, and they are going to do something which I am not going to disclose at this time, because as students from the different RIEs, they have planned something for you. So therefore, I will keep that as a suspense. Another thing is that you may be wondering, why is it that we are having this national conference from today and ending it on the 22nd of December, and that too in Shillong, a very cold place. I met participants from Pondicherry who told me that, madam, it is cold, but we are enjoying the climate. I will not tell you the reason, because gradually the program is going to unfold. I know that most of you will know, but for some of you who do not know, gradually you will know as the program will unfold. I also extend a hearty welcome to each one present here. I thank the administrative officers of the Institute, the senior faculty professors, Professor Professor Pradhan, Professor Subhash Chandra Roy, Madam S. Palit, and to all the heads who are here, to all the faculty members, to the staff, and to everyone, a very, very warm welcome. And with that, I also extend a very warm welcome to the members of the media. We have with us from the All India Radio Shillong, and some also we have from the leading newspapers from our city, Shillong. Thank you so much for being here with us. I know that you will be spending 3 days here with us, but mind you, we will hope to see that you will go back. People who are being enriched, people with a new vision, people with a new attitude towards mathematics education, which is so important. We know about the importance, how much of importance mathematics education has been given worldwide. And not only that it is being given in our Western countries, but here also in our country, India, where the National Education Policy 2020 has really emphasized on this. So therefore, to all the delegates and to each one present here, I know that it was going to be a fruitful event, and we will ensure that during the valedictory session, we are going to come up with some strong recommendations on the discussions that we will be having on all these 3 days. I wish the two coordinators, Dr. B. Davy and Dr. T. Day, who has been working tirelessly, and to all the heads and the committee members, the very best for these 3 days. Thank you.
Thank you so much, ma'am, for such a warm welcome to all present in this auditorium. And thank you also for setting the tone for these 3 days. And at this moment, we would like to felicitate our guests for the day, and I request Madam Principal to do the honor. Thank you so much, ma'am. Yeah. Quickly, we would like to just talk a little bit about organizing this conference, as the keynote address speaker will be joining at 11 a.m. sharp to address you all. So without taking much time, friends, organizing a conference has its own objectives, and when it is a conference on mathematics education, we understand it is very vital not only for this institute, but to the community at the large. Mathematics is a fundamental part of human thought and logic, and integral to attempts at understanding the world and ourselves. Mathematics provides an effective way of building mental discipline and encourages logical reasoning and mental rigor. Mathematical literacy is a crucial attribute of individuals living more effective lives as constructive, concerned, and reflective citizens. Furthermore, since mathematics provides foundational knowledge and skills for other subjects such as sciences, economics, arts, etc., there are almost all subjects mathematics touches them. The issue of how mathematics is intertwined with other school subjects deserve to be addressed, and that perhaps is what we are looking into in the new curriculum and also the textbooks. And this reform, the NEP 2020, has also envisaged necessary reform to strike a balance between the need for 21st century employment and entrepreneurship, skill which is characterized by lateral, critical, and numerical thinking. At this backdrop, the National Conference on Mathematics Education has been organized with the broad themes on mathematics education and intends to focus on traditional knowledge in mathematics education, mathematics in school curriculum, mathematics learning, issues and concerns, innovative practices in mathematics education, recent development in mathematics education, learning resources for mathematics education, professional development of teachers, and popularization of mathematics education. In this context, the mathematician educationist, teacher education, teacher educators, research scholars, academicians, and teachers in the field of mathematics and education are today in the same platform to share their thoughts, experiences, researches in the conference which is being held by NCERT at NERIE Shillong to observe the National Mathematics Day on 22nd of December and to mark the birth anniversary of Indian mathematical wizard Srinivasa Ramanujan. A total of 140 papers were received by the committee for presentation in the conference. The papers were screened thoroughly by the expert advisory committee of the conference, and 93 papers were found to be satisfactory to be presented in this conference. The modalities of the screening of papers were all the papers were sent for blind review to 2 experts. Some of the papers were accepted without any change, and some of the papers were sent back to the authors for some changes as per the comments received from the experts. On receiving the revised papers, they were again sent to the experts, and only after receiving the final nod from the experts, you all were invited here to present the papers today. So with this backdrop about this conference, I also join my principal once again to welcome you to this 3 days deliberation and hope that your deliberation will throw some light as we are at a point where the revision of textbooks, revision of syllabus is taking place. So looking forward for some meaningful deliberation. Yes, at this time, I also recall what Albert Einstein once said, and I quote, "We owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery could have been made." So that shows the kind of impact Indian mathematicians have in the global scenario. Friends, the number system, the zero, the decimal system, algebra, trigonometry, calculus, and even the game of chess were all invented in India. In the early 15th century, Bhaskaracharya calculated the time Earth took to orbit the sun. And carrying forward such legacy, Srinivasa Ramanujan's contribution to the field of mathematics is perhaps the greatest. Thus, our achievements in mathematics in India is incomplete without Ramanujan. Therefore, at this moment, I request all the dignitaries on the dais to offer flowing tributes to the great Indian mathematician, late Srinivasa Ramanujan. His birthday is on 22nd of December, the National Mathematics Day. But we celebrate it for 3 days, and as we celebrate his birthday, we recall his natural ability in mathematics at an early age. This great Indian talent died at an early age of 32, but before that, he produced an exceptional output in mathematical analysis, number theory, infinite series, and continued fractions. So, ma'am, should we all proceed? Yeah, thank you. I think Professor Manjul Bhargav has joined us, and may I now request Professor Anup Rajput to introduce the revered, the much-awaited speaker to the August gathering.
Very good morning to all of you. Esteemed Minister Education sitting on the dais, ex-director Professor G. Ravindra, principal of this institute, and other faculty members, and my dear colleagues sitting in the auditorium, and all participants of this 3 days national conference. First of all, I'll congratulate all of you that your paper have been selected for presentation. This is a great opportunity for every one of you and for us also to learn, and as has been mentioned by Professor Dakar, that ultimately in the end of this workshop we should have some strong recommendations which we should make, particularly to the policymakers, to the material developers and so on, so that the teaching learning of mathematics becomes fruitful and joyful to the learners of this country. I have this privilege of introducing or saying few words about Professor Manjul Bhargav. You have heard many things about him from Professor Dakar. You already probably may be knowing him, and he is commonly known for his work, particularly number theory, when he was awarded field medal, which is considered to be equivalent to Nobel Prize in mathematics. Professor Manjul Bhargav is a distinguished Canadian-American mathematician who has made significant contributions to the field of number theory. He currently holds the position of Branford Class 1983 Professor of Mathematics at Princeton University, as well as the Professor of Number Theory in Leeds University. Then he is also an adjunct professor at the Tata Institute of Fundamental Research and IIT Mumbai also, and one of the university in Hyderabad. So he is very well known, particularly not only in world but in India also, and is working very, very closely in order to improve the teaching learning of mathematics in India. One of the Professor Bhargav's notable achievements is being awarded the field medal in 2014, the highest honor in the field of mathematics. The International Mathematics Union recognized him for the groundbreaking work in the area of geometry of numbers, where he developed powerful new methods. These methods were applied to count rings of small rank and to bound the average rank of elliptic curves, showcasing his profound impact on advancing mathematical knowledge. Apart from his contributions to the research, Professor Bhargav has been actively involved in the academic community. In 2017, he was elected as member of the American Academy of Arts and Science, a testament to his standing in the mathematics community. Additionally, in 2018, he became the inaugural occupant of the distinguished chair for the public dissemination of mathematics at the National Museum of Mathematics, MO Math it is called. This position highlights his commitments to raising public awareness of mathematics, making him the first visiting professor in the United States dedicated exclusively to this important task. Professor Manjul Bhargav accolades also extends to national recognition, as he was awarded the Padma Bhushan in 2015, the third highest civilian award in India. Furthermore, his involvement in the prestigious Padma Award committee in 2023 underscore his ongoing impact and influence in the mathematical and academic communities. Overall, Professor Manjul Bhargav's multifaceted contributions ranging from groundbreaking research to public engagement mark him as a leading figure in contemporary mathematics. As has been mentioned, he was the chairman of the National Syllabus and Textbook Committee. He is keenly involved in development of national education policy, the national curriculum framework at foundational stage, at school education, and now he is working on national curriculum framework for adult education and for teacher education. He is also vice chairman of the textbook writing committee at the preparatory stage, for which he is very, very busy. And before he starts, let me just pay my sincere thanks to Professor Manjul Bhargav, who accepted our invitation. Despite his very, very busy schedule, he has accepted this invitation. We are very highly thankful to you, sir, for accepting, and we are looking forward for your address to our budding mathematicians, our teachers who are taking up mathematics education in the classes in order to develop India, country which certainly will be a developed country in few years, and in that mathematics has to play a very, very important role, for which your contributions are notable, and we all are also working for that. So thank you very much, sir. I invite you to present your speech for our participants here.
मेरी आवाज आ रही है?
Yes, sir. Everything is set and the time is yours. Thank you, sir.
Okay, you
for
can hear
joining.
me all right? Okay, thank you so much. Well, thank you very much, Anoop ji, for those kind words, embarrassing words. Appreciate it. Honorable Education Minister, Shri Sangmanji, Director RIE of the Northeast, Professor Dikhaiji, Anoop Rajputji from NCERT, former Director of NCERT, Professor Ravinderji, and convener, Dr. Deviji, and to all the distinguished participants of this conference, math teachers, math students, we're all math students here. A very warm welcome and Sadar Namaskar. It's a real honor to be with you. I wish I could have been there in person for this most important conference. And I really appreciate and I'm honored to have the opportunity to be with you, at least online. So thank you very much for that. Thank you very much for the invitation. And I just want to wish everyone an excellent start to this most important conference on mathematics education, this National Conference on Mathematics Education. I do hope, once this work with textbooks is done, I do hope to visit you in person as well. I've never been to Shillong, and never been to the RIE there in particular. So hope to be there in person sometime, but at least this is a start. I get to be there with you online. So thank you very much for that. You all will be discussing some of the most important issues of mathematics education that face our country today. Mathematics education, as we all agree here, is one of the most important facets of education because it connects to every aspect of every other subject and connects to every aspect of life. And so the progression of mathematics education to make it more modern, to make it more interesting, to make it less scary for all our students is our primary goal at all times, is what we continuously strive for. So maybe just a couple of things that I feel we should all keep in mind as we're trying to advance mathematics education in the country. The first, as we all know, is that when we did surveys, for example, in writing the national education policy, we asked about how students felt about each subject. And so, for example, when we talked about social science, the most common complaint was that they found it boring, hard to remember, too much rote learning. That's what they said about social science. For mathematics, the most common feedback is that they find it scary. They find mathematics scary. And we all, as mathematics enthusiasts here, we know that mathematics is not actually scary. It's fun, it's enjoyable, it's enlightening, and elegant. These are the words that mathematicians use when they describe their subject, elegant. So what is it that we're doing in schools that is not passing on that bhav, that feeling that we have towards mathematics education? And of course, it has to do with the way it is being taught. And it has a lot to do with an overloading of the syllabus, making it very mechanical, because when the syllabus is overloaded, then all the teachers are trying to just get through the syllabus, and the subject ends up being very mechanical instead of enjoyable, instead of discovery-oriented, instead of activity-oriented. So maybe the very first principle, which was also the very first principle of the NCF in revamping education, and in particular mathematics education, is to lower the content load so that we are given the time to really discover the ideas of mathematics, so that students are given the time to really discover the ideas of mathematics, the techniques of mathematics, and the overarching concepts of mathematics, which indeed are so elegant. So we definitely want to move towards more activity-oriented learning, more discussion-based learning in mathematics, so that students have that opportunity to discover, which is what we mathematicians enjoy so much about the subject. We all feel like we're explorers, discovering truths about the universe. That feeling has to come across to the students as well. And so if we try to present theorems by having students discover it for themselves, by doing examples, looking for the patterns, and then making deductions on what they see, and then trying to understand why what they see is true and will always happen, that process of discovery and activity can really help students realize the elegance of mathematics, the aspect of adventure, exploration, discovery. So that I think is the very first thing that we need to keep in mind when we're revamping our mathematics education system across the country. We want to dispel this notion that mathematics is robotic and mechanical, and instead bring about the notion that it's a discovery-oriented process, an exploration, and adventure. So that, I think, is perhaps the most important thing to keep in mind when we're thinking about how to change mathematics education in this country and around the world. And that can only be achieved when the content load is less, so that there is adequate space given in the classroom hours to really spend time discovering, looking for patterns, and just playing around with mathematical ideas. So that's the first thing I wanted to say about the new directions for mathematics and mathematics education. And the second thing I wanted to say is that sometimes mathematics is really taught in isolation, or at most, it's taught as a part of the sciences. And what I really wanted to emphasize a little bit today is that mathematics is also very much connected to the humanities, to the social sciences, to the arts. And that's an aspect of mathematics that we don't see in mathematics education every day. But I think we should. In fact, if you ask a mathematician, a pure mathematician, whether they think their subject is a science or an art, most mathematicians will answer, it's an art. So we mathematicians, when we work, we really think of our subject as an art. Indeed, we use words such as beautiful, this theorem is beautiful, this theorem is elegant. The kinds of words that we use to describe the objects that we see in our subject are the very same words that artists use to describe concepts and ideas in their subject. So mathematics really is an art, and it has connections to the arts and to the humanities. And those are aspects of mathematics that we really do want to try and emphasize more than we traditionally have. And so that would be my second point, is that we should really, in addition to showing the discovery-oriented and activity-oriented side of mathematics, the adventure and the exploration, we should also show how mathematics is connected not just to the sciences, but to the arts and to the humanities, the aesthetic side of mathematics, not just the analytical side of mathematics. In fact, for me personally, I got interested in mathematics less through the sciences and more through the arts and humanities. So traditionally, we see that most students get interested in mathematics through the sciences because that's how the subject is presented in school. But it's always been my passion to try and get more students interested in mathematics also through the arts and through the humanities. And that happened to me personally as well. The reason it happened to me, the reason I got interested in mathematics through more arts and humanities subjects, is that my grandfather, my Nanaji, was a professor of Sanskrit at Rajasthan University. And I used to take off a lot of time from school. Months at a time, I would leave school in the United States and come live in Jaipur and learn from my Nanaji, who was a Sanskrit scholar. And so a lot of what I learned about mathematics growing up was from what he taught me about the rhythms of Sanskrit poetry. And I ended up learning a lot of mathematical ideas through my study of linguistics and Sanskrit and music with my Nanaji and with my music teacher there in Jaipur. And I always loved mathematics since I was as far back as I can remember. But I used to love seeing mathematics in everything, and in particular, seeing the mathematics of poetry and of music and of linguistics was what personally drew me into mathematics. And so it's my request that some of our mathematics education also move in that direction, not just connect mathematics to sciences, but also connect mathematics to linguistics, poetry, art, music. And I'll give you a few examples now of how it happened to me personally, and then of course you will also all have examples in your own lives, and if we can infuse these kinds of ideas into the mathematics curriculum, that can only bring more people into mathematics. Basically, I think we should show and tell some of the interdisciplinary stories of mathematics. So I'll tell you just a couple of quick set stories. So one of the most creative inventions in human history that happened because of interdisciplinary thinking is the discovery of zero. And that's a story that happened in India. And it's a story that every student should know because of how inspiring it is, because it shows, first of all, one of the most creative inventions of all time. And it also shows how interdisciplinary thinking led to one of these most creative discoveries of all time, which happens to be in the field of mathematics. So how did the notion of zero come about in our world? So a lot of us have seen this T-shirt that says India's contribution to the world is zero. How many people have seen that T-shirt? So it says India's contribution to the world is zero, and then there's a subtitle that says, "We always knew we were good for nothing." So this is a famous T-shirt that a lot of us wear. I also have one. And so because of T-shirts and just people discussing this topic about zero, that zero was discovered in India, India's contribution to the world is zero, because of that, everyone is familiar that zero originated in India. But very few people are actually familiar with what that means. What does that mean that zero was discovered in India? What does it mean to discover nothing? It actually means something very significant. The concept of zero, as it's used in mathematics, is actually very, very deep and very, very creative, and it's what allows us to write numerals the way we do today, using just 10 symbols, 0, 1, 2, 3, 4, up to 9. We can write any number, however large or however small, just using 10 symbols. That's pretty amazing. And it's the first time in human history when Indian numerals came about, just using the numbers 0 through 9. That was the first time in human history that we could write numbers, any number, however large or however small, just using 10 symbols. Just to put that in perspective, think about the previously most common used way of writing numerals before the Indian numerals came about, or the Roman numerals. And in the Roman numerals, each time you have to write down a much larger number, a new letter has to be introduced. When we got to 50, L was introduced. Then when we got to 100, C was introduced. And then when we got to 1,000, when we got to 500, a D was introduced. And then when we got to 1,000, an M was introduced. So for each higher number, a new letter was introduced. And when one runs out of letters, one runs out of numbers. So there was a limit to how large numerals one could write using Roman numerals. Moreover, imagine having to multiply or add large numbers using Roman numerals. There's no way. There's no natural method in which to do that. And so it's severely hampering in doing higher mathematics if one is using only the Roman numerals. So when Indian numerals were introduced, just using 10 symbols to write arbitrarily large numbers in the systematic way, which made it possible to add and subtract and multiply and divide easily with clear algorithms in the systematic way, was something that really changed world history. And so this is one of the most amazing inventions of all time. And yet very few people in India, the system was discovered in India, in Greater India, and yet very few people in India actually know how this came about. And so that story is actually one of the most inspiring stories of all time, and one of the most creative stories of all time, and one of the most interdisciplinary stories of all time. So maybe I'll just say a few words about how this came about, because we all say zero, the concept of zero originated in India, but what does that mean? Well, there's sort of three conceptual landmarks in the development of the zero in India that really set the stage to take on the role in mathematics and science that it does today. The first is just the concept of the zero. Zero as a concept. The fact that the void, nothingness, can actually be something significant. And this concept of zero was in the air philosophically in India for quite some time, going back thousands of years. Second, then there was the development of a symbol for zero, including its use in the Indian numeral system that we employ today. As I said, using 10 symbols to write arbitrarily large numbers. So first was the concept of zero, then there was a development of a symbol for zero, and then the final and the most perhaps significant landmark was the recognition of zero as an actual number, on an equal footing with any other number. And so these are the three conceptual landmarks of zero. Zero as a concept, zero as a symbol, and then zero as a number. And all three of these steps that are very important in the understanding of zero today actually happened in India. So first, the philosophy behind the zero, that nothingness or emptiness or the void is actually something worth thinking about. Such a concept of zero, the importance of zero or emptiness, started off in philosophical texts, in the Upanishads and in the vast Buddhist literature that goes well before the 7th century BC. The word for zero is shunya. Shunya means zero. And the word shunyata was used extensively in these works, these ancient Indian works, to describe, for example, the state that one is trying to achieve during meditation. That is the state of emptying one's mind of all sensations and thoughts and emotions and ego in order to achieve the state of shunyata, or zero-ness. In fact, Patanjali in the Yoga Sutras, around the 3rd century BC, also describes how shunyata can help lead to control over one's body and mind and senses. So this philosophical notion of zero and zero-ness was there in the air in India for many centuries. This idea that zero-ness is actually something that's very positive and something that we're trying to achieve, and it's really something significant. So that concept of zero-ness first came about in philosophy, which is kind of amazing. This is what the interdisciplinarity that I'm talking about in making great discoveries in any subject. And in mathematics, that's no exception. The concept of zero first found its way into our thinking through philosophy. And once it was there in the air philosophically, it found its way into many fields, such as architecture, literature, linguistics, and eventually mathematics. So this is the concept of zero. The second aspect, and the second landmark in the development of the zero, is the development of a symbol for zero, if only just as a placeholder in order to develop the Indian numeral system. Zero as a symbol perhaps occurred first in linguistics and poetry, not in mathematics, but in linguistics and poetry. For example, in Panini's Ashtadhyayi, there's a concept of lopa, elision, deletion, where, for example, the a sound at the beginning of a word is sometimes deleted, but is still notated as a letter. It's called an avagraha. So avagraha is used as this placeholder for emptiness. And the avagraha is a symbol. It looks like an S in English. It looks like the English letter S, an avagraha, that you've all seen if you've studied music or poetry. That is just as big as all the other letters. So this emptiness, this symbol for emptiness was used, this avagraha was used as a regular letter, even though it represented the empty sound. So the symbol for zero was also invented in India, but not in the context of mathematics, but in the context of linguistics, in the works of Panini and in Pingala. And then finally, the third landmark in the history of the zero is actually recognizing zero as a number. And Pingala, the linguist around 300 BC, even though he was a linguist, actually mentions zero not just linguistically like Panini did, but also mathematically. He talks about taking a number and repeatedly dividing by 2, keeping track of the remainders until one reaches zero, shunya. And this also incidentally gave an algorithm to convert any numeral into its base 2 representation. And the first surviving manuscript in which there's an actual symbol for zero in a mathematical context is found in the Bakshali manuscript, which was composed perhaps around the year 300, where a 6-digit number and some 3-digit numbers are found. And the symbol zero there was written as a dot. So the symbol for zero in a mathematical context first comes about, as far as we know, in this Bakshali manuscript. That's the oldest surviving manuscript in which we have a zero. And the zero there was written as a dot. So it was kind of written as a placeholder. It wasn't recognized fully as a number, but it was used as a placeholder to write numbers the way we do today. And that goes back to the year about 300 in the Bakshali manuscript. And this way of writing numbers had already become standard by around that time, because there's a 4th century love story and novel called Vasavdatta by a writer named Subandhu that's full of ornate language and full of metaphors and similes. And one of those similes talks about how the stars above were shining like 0 dots scattered across the sky. So that's in the 4th century. So it was already in the popular culture, in other words, this idea of 0 being used as a placeholder in writing numerals was already there back in the 4th century in India. And while Aryabhatta explained the place value system and the use of 0, there's also Vyasa, who explains how positional notation works in more figurative language. He writes that a 1 can mean 100 or 10 or 1, depending on its position, just as the same, a lady can be referred to as a grandmother or a sister or a daughter, depending on their position. So you know how in our numeral system a 1 can mean 100 or 10 or 1, depending on where it is in the numeral. In the same way, a lady can be a grandmother or a mother or a daughter, depending on her position. So this explanation in just popular works shows that this understanding of 0 and the positional notation system and the idea that 0 is a placeholder in the writing of numerals goes back all the way to the 3rd and 4th century, where it was already common amongst the public. So finally, for mathematicians, the most important landmark, the 3rd landmark, so we already saw 0 come up as a philosophical context in a concept which goes back thousands of years in the literature on meditation, Buddhist literature, Upanishads, then as a symbol which came across in linguistics, in Panini, in Pingala, and then in Aryabhatta and Vyasa in the mathematical context. And then finally, the 3rd landmark, the most important one for mathematicians, is the development of the 0 as a number in its own right. That 0 is not just a placeholder, but it's on an equal footing with all other numbers. That 0 is as important a number, if not more important than all other numbers. And this incredibly important contribution is that of the legendary mathematician Brahmagupta in his book Brahmasputra Siddhant, which he wrote in the year 628. And among the many new mathematical ideas he contributed to the world, one of his most impactful is the introduction of 0 as a number. So prior to Brahmagupta, numbers meant 1, 2, 3, and so on. But in his book, Brahmagupta talks about 0 just like any other number. He describes rules of arithmetic for 0, saying that, for example, 0 plus any number is the same number, 0 times any number is 0, and so on. He writes the rules of arithmetic for 0 for the first time. So this is Brahmagupta in the year 628. And that, in the year 628, is when 0 became a full-fledged number, just like any other number. And that really is Brahmagupta's incredible contribution. And this pivotal moment really changed mathematics, because not long after Brahmagupta's work, then, we start to find this dot. Remember I was saying in the Bakshali manuscript, 0 was written as a dot. So it wasn't written as a full-fledged number, it was just like a placeholder. But not long after Brahmagupta's work, we start to find the dot that represented 0 start to increase in size. It starts as a dot and it starts to get bigger and bigger and bigger, as if to take its rightful place as an equal alongside its fellow numbers. And so after Brahmagupta, that dot starts to become bigger and becomes a circle that's written as big as other numbers. And now today we of course always write 0 just as big as all other numbers. And that really happened because Brahmagupta explained that 0 should be treated just like any other number. It's just as important, if not more important, than every other number. And it has its own rules of operations for addition and subtraction and multiplication and so on. So for example, there's an inscription at the Chaturbhuj temple in Gwalior, which was built in the year 876, so just a couple hundred years after Brahmagupta, where we have a very clear round 0 the way we write it today. It's not a dot, but a circle of a similar size to all other digits. The number written there is 270, with a big 0 at the end, describing the length of a side of the land that the temple is built on. And so from Brahmagupta's time onwards, 0 became just a regular digit and just a regular number across India. And once that happened, well, the rest is history. So that's around the year 800 that it became a full-fledged number in India, and numerals were written with full-fledged zeros around the year 800. And then this Indian number system was transmitted to the Arab world It was popularized by the great Persian mathematician Al-Khwarizmi. He wrote a book called On Calculation with the Hindu Numerals. Hindu there referred to the people around the river Sindhu. Hindu refers to the people of a geographic region, not a religion. But so on Calculation with Hindu Numerals, he wrote this manuscript in the year 825, after whom the world algorithm is named, Al-Khwarizmi. So Al-Khwarizmi wrote this book called On Calculation with Hindu Numerals. And Al-Kindi, the great Islamic philosopher, also wrote a book called On the Use of Hindu Numerals in the year 830. And so these two books by Al-Khwarizmi and Al-Kindi really popularized the Hindu numerals, the Indian numerals, in the Arab world. And then from the Arab world, it was transmitted to Europe by around the year 1100. And the Europeans, therefore, mistakenly called them the Arabic numerals, the Arabic number system, since that's where they learned this from. And this is now being corrected in textbooks, even in Europe now. They learned it from the Arabs, so they call it the Arabic numeral system. But the Arabs, of course, called the numbers Hindasa, coming from India. And so that's something we should also fix in Indian textbooks, show this beautiful story. And through Al-Khwarizmi's works on Indian numerals were translated into Latin. And it was Fibonacci who, around the year 1200, really made the case to Europe that one should switch to these numerals rather than Roman numerals. Nevertheless, the Roman numerals were ingrained in European thinking, and so there were some philosophical and religious objections. Again, it all comes back to philosophy, which really shows the interdisciplinary nature of all thinking. But Roman numerals were ingrained in European thinking, and so there were some philosophical and religious objections to the Indian numerals. There was at that time, after the Crusades, there was this feeling that anything coming from the Arab world was evil. And so the Indian numerals did not gain widespread usage over the Roman numerals in Europe until about the 17th century, 900 years, more than 900 years, more than 1,000 years after they were already being in regular use in India and then in the Arab world. And in particular, there were writings of the time in Europe that 0 is associated with Satan, and because it was coming from the Arab world. And so it was just not adopted officially, although people in secret were using the Indian numerals rather than the Roman numerals to do their calculations, merchants and scientists. And it turns out that in 1299, Hindu numerals were banned in Florence. It was the official reason that they were not adopted officially, was that they were banned in Florence by the church. The official reason being that they could promote fraud. But eventually, over the period of the Renaissance, scientists realized that not adopting the Indian numerals would impede progress, scientific progress and trade progress. And so finally, in the 1700s, they were officially adopted, and the rest is history. It's what has allowed all the scientific contributions of today. Without 0, we would not have been able to do all the advances in computers and cell phones and smart TVs. It just wouldn't have been possible. So I love telling this story, and I think all children of India and the world should know it, because it shows how interdisciplinary thinking led to one of the most creative inventions of all time, the 0. 0 looks like the wheel. We always talk about how the wheel is one of the great inventions of all time. And 0 looks just like it and is also one of the greatest inventions of all time. And it happened in India, and it happened through interdisciplinary thinking, going from philosophy to linguistics, to poetry, and then to mathematics. And first as a philosophical concept, then as a symbol, and finally as a full-fledged number, which allows all the mathematics and algebra and technology of today. So this is a really great story. Thank you for giving me the time to tell it to you. It's one of my favorite stories. I think it's very inspirational. There are many other stories like that. The story of how the Fibonacci numbers were invented in India also comes through linguistics. The story of how algebra was first presented in Brahmagupta and then in Bhaskara through poetry, again, shows the close link between mathematics and poetry. So these kinds of interdisciplinary thinking, it really influenced me when I was growing up in India. I was lucky that I had someone in my family, my grandfather, who was very acquainted with Indian literature, and I got to learn mathematics through some of the works of ancient Indian literature. But just generally, teaching mathematics through interdisciplinary ideas, really do think about that. how it connects to our everyday lives, how it's really changed our lives. That will really open the eyes of students to how exciting, how interdisciplinary, how the journey of mathematics, how it's so exciting and adventurous and life-changing. So thank you for that opportunity. Have a really wonderful conference coming up. I wish I was there with you, but definitely next time. And thanks to everyone for the incredible work that they do for mathematics and mathematics education in the country and around the world. I'm really grateful. We all are so grateful to all of you for what you're doing for the country. Thank you. And all best wishes for a very, very successful conference. Thank you so much.
Thank you so much, sir, for joining us for this very, very important conference on mathematics education. And within a very short notice, sir could join us, and he, yes, really has made us think so much about it. And I'm so happy to hear that how being in Canada, in the US, he used to come back to India during his holidays to learn from his Nanaji, and from the Sanskrit, he could, through the Sanskrit language, he has learned so much of mathematical concepts. And we really fall short, and I'm so very ashamed to say that I'm standing here and we have never tried to look into these rich languages through which so many concepts could have been learned. So thank you so much for showing us this light. And also that I was mentioning before that maths has been intertwined into so many other subject areas. And when Sir says that it is so beautiful, it is so elegant, it reminds me of Leonardo da Vinci's most visited, most acclaimed portrait of Mona Lisa, which is nothing but a mathematical portrait being made. So there lies the beauty of, or the aesthetics of mathematics. Sir has so rightly pointed out, and it has made me think so many things about it. And he also appealed everyone to see the aesthetics in mathematics. I think that is what we need to see. So it is not that beauty lies in the eyes of beholder, but beauty lies in mathematics. That is the golden ratio that he is talking about probably. And there, anyone who is beautiful or anything that is beautiful is something which follows actually the golden ratio. So beauty doesn't lie with the eyes of the beholder, but it lies with mathematics. That is the essence. And I'm sure Professor G. Ravindra is here with us. He is also going to talk so much on these aesthetic aspects of mathematics, and I have heard before him also speaking on this, and today when Sir spoke about it, I felt so very good to hear that. Sir has also mentioned so much about the discovery of zero, and not that we Indians are useless with zero, but he has so beautifully explained the concept of zeroness with the state of sunyata in meditation, the thinking, and it has been really amazing. The symbol of zero, how it developed in India, and the very beautiful part, I think, what he has in the beginning said, that scary about mathematics. Are we really should be scared about mathematics? And he said that this is what he doesn't like, and he is working on it. Really, and that beautifully how he explained the place value with a lady's position as grandmother, mother, daughter, so beautifully related that with the position. The place value has been explained. So, sir, there has been so much of learning from this that you have spared your time and shared your thoughts with us. I hope we could have heard more of you, and this would have given us enough directions to this. But nonetheless, we appreciate that in spite of your busy schedule there, you have spared some time with us. Thank you so much, sir. And the whole of the NCERT's mathematics faculty and the non-mathematics faculty to join me at this moment to thank you profusely for joining us and showing us the light. Thank you so much, sir. At this moment, I would like to say a sincere apology to Professor G. Ravindra. We had to skip, sir, because of sir's timing, because sir had to join right at 11 o'clock. So we had to skip the inaugural speech of Professor G. Ravindra. We took the privilege of just scheduling his speech after Professor Manjul Bhargav. I hope sir doesn't mind. So at this moment, I would like to request Professor G. Ravindra, a man of mathematics that you all understand, NCERT, and since 1976, he has grown in NCERT from a lecturer, through reader, professor, principal of RIEs, joint director, and retired as the director in charge of NCERT. So there has not been a single capacity which he has not touched. A man grown as a mathematician in NCERT, has touched on the lives of so many people and has been a pathfinder for all of us. Thank you, sir, for being here. And as Manjul Bhargav sir said, maths enthusiast, sir is one person who is so very enthusiastic and has been constantly inquiring about the developments of this program, I think for last 2 months with me. And so I'm so happy to see sir here, and we all will be benefited by his presence here. Not to talk much of his academic contributions, he has more than 45 research publications and so many other things. Tomorrow also he will be with us. We will throw some light tomorrow too. And with this, I request Professor G. Ravindra to be here to deliver his inaugural speech.
Shri Sangmaji, the Honorable Minister of Education, Meghalaya, we are very, very happy that he is with us. I think we are also very happy that you have given 20 acres to NERIE-Shillong. That's what the principal said. So very, very happy, sir. I won't say, I won't take more than 2 minutes because I will talk about aesthetics and all tomorrow. We have Professor Arup Rajput, also the principal of this institute, and then the dean. See, I only want to say that NERIE-Shillong has come in a big way, and many achievements. There's a B.Ed course here, and it caters to the needs of northeastern regions, and we are very happy about it. But NERIE lacks something in mathematics. Maybe there's an area where we will not, all of us, including me, will not do much. What is needed to be done is in mathematics and mathematics education. The teaching of mathematics, it doesn't come from an empty set. Many people in education, they think that education can be taught without content and all. I think that's wrong. I think mathematics education has mathematics at the center. It starts from the numbers, and numbers are everywhere. In 18th century, Mahavir Acharya said that numbers are in Akasha, numbers are in Dharti, Bhumi, and also in Patal. That means it's everywhere. Numbers are here, numbers are in political science, numbers are in physical education, numbers are everywhere, numbers are here, everywhere in this room, everywhere on this earth. So that is the great thing about mathematics. It's everywhere. There's no place where no numbers are there. So I think if that is the assumption, I think we cannot live without mathematics. So mathematics has to be connected to the society. It is connected, knowingly or unknowingly, but will have to be connected more. This conference is going to do something in that direction. So the second thing, mathematics, many people think that it can be, mathematics is a science, mathematics is logic. No, mathematics is neither logic nor science. Mathematics is art. Mathematics is human science. So mathematics full of aesthetics. The maximum contemplative beauty is mathematics. The big chunk of mathematics is in the world is mathematics. I think that's the great thing about mathematics. Let's all go with that great thing that we cannot live without mathematics. So thank you so much.
Thank you so much, sir, for your short but lucid speech. And yes, we will get to hear him more tomorrow. And as we are running short of time also, so we, without much time, I would now like to welcome the chief guest for his deliberation. And today's chief guest, as we have already said, that he is Sri Rakham A. Sangma, the Minister for Education Department, Government of Meghalaya. But besides education, he also has Border Areas Development and General Administration Department too under him. He too is a man of science. He has a master's degree in physics and started his career from the Bagmara Higher Secondary School. So much, such a befitting person for this conference, and this address, valuable address that he is going to bring about, connecting it to school education. And we are so happy, sir, that you are here amidst us, and definitely your presence will guide us, will help us to understand the nitty-gritty that is there in the region and how to go about in the near future. And our presence here in the state also should make some difference, and that is why we are looking forward to your speech. Yes, sir, please.
Very good morning to one and all. At the very outset, I'd like to welcome all of you to the beautiful state, our state, Meghalaya, above the cloud, but very cold. I'd also like to wish you, on behalf of my family, on behalf of the Honorable Chief Minister, Sir Conrad Sangma, and the entire cabinet, and on behalf of the government of Meghalaya, we'd like to wish you a very blessed Merry Christmas to all of you. Our dignitaries on the dais and on the online, Professor Bhagav and Professor Rabindraji, the former director of NCERT, Professor Rajford, Madam the current principal, Professor Devi, and Madam Professor Chairperson, and all my dear respected faculty members from different universities, different states, and my dear students and teachers. This is something I don't know what to speak. The politicians seem to speak to the mathematician. But I was thinking on the way that the politicians and the mathematicians are the brother and sister. And you will see this quality in me now. So I'm just thinking all the way around that had it been all the mathematicians become politicians, we would have seen a different world. Because why I'm saying, people as Bhagavad and Professor Ravi just said, that our students, our people, scared about the mathematics. I asked my young daughter, she is just 10-year-old, she's very love of mathematics, because father loved more. I love her. So she loved mathematics so much, and she knows she's just class 4 now. She's very patient for the mathematics, as father did. So I asked her, Mommy, you want to become MLA like me? So she said, no. She said, no, why? Why don't want? Hari Papa, to become politician, I don't know, I will not able to meet all the people. You talk points over here, and you meet people, 1,000 people a day. You have to all this. She's saying, I'm just saying why. People are scared for mathematics, but more beaten about to become politicians. Because the politicians, we always think about how to balance the things. We always think about how to find a solution. The whole theorem, the whole idea, the mathematics, if we don't reach to the result, it doesn't make sense. It doesn't make sense. We write all the theorems, all the formula, but if we don't reach the result, it's become zero. It becomes zero. So therefore, as a politician, when something happens, be it law and order, be it policy making, be it any decision, we have to find a way how to find a solution. We have to apply so many formula, we have to redesign, we have to find out the ways how to find a solution to see the result. But to me as a mathematician, to me as a politician, I'm very much patient. I'm very happy to be in the profession of politics and as a mathematician, as a physician today, because we see more formula. Therefore, I'm just saying, had it been all the mathematicians become all the politicians, we would have seen more ideas and more formulas to find a solution. So, Madam Principal, thank you so much for inviting me, and it's my pleasure and honor to be here in the midst of a great people, the great people. To me, as we say that many students don't want to study mathematics and fail in the subject. But today, I want to remind each one of you, it is not the students, it is not the textbook, it is not the curriculum, it is the failure of the teacher who make students fail. Because as a teacher, we have failed to inspire, and the approach of our formula was not correct. And today, as our speaker has stated, as academicians, as a mathematicians, as a teacher today, we should redesign the formula of teaching innovative so that this mathematics will become friendly to our students. There was a teacher during my school time. We always ask, throw out the question here and there. We sit on the back bench and we ask, sir, wala X kaise aaya? He was impatient. His name is Sir Ram Shankar. I think he said he was impatient. He was God angry with me. So, Rakam, you don't know. Asman se, he told me. So, sometime as a teacher, the approach of teaching mathematics should be in a different way, that it really inspire the students. Therefore, it is not the students, but it is the teacher who fail to make them pass, who make things easy. And today, as our NCERT chief are here with us today, I would like to reiterate, I would like to say to all the academicians, even for the NCERT officials today, there are many, maybe theorems, there are many formula mathematics, but when we design our curriculum, when we design our textbook, it is also important to understand the capacity of our students. Therefore, accordingly, with a limit, and with understanding the strength of the students of the age and the classes, we should develop the textbook, the curriculum. I think it is already doing it according to the strength that our students can respond to the demands of the formula. And also, as the time changes, sometimes theory also changes. Even sometimes we see the summer begins from May to some August, September, but the climate changing. Sometimes we should adopt our formula too. The formula that all are 50 years old may have to redesign today, may have to modify today. Therefore, there may be some formula, some theorem that mathematicians today have to rethink and redesign today. On this auspicious occasion today, as a national conference on mathematics education, I also pay tribute to a great man, Srivasa Ramanujan, Indian great mathematicians. Maybe thousands more Ramanujans we should come out to impact the world of mathematics. And as mathematicians, of Indian mathematicians, should contribute towards the growth of this sector. So today, mathematicians are the great pillar of any governance of the world, of the system. And today, what the position of the world today, it's because of great leaders, great mathematicians of yesterday. And the future of tomorrow, be it science, technology, be it the education system, be it any topics, will be decided by the strength and the quality of today's mathematicians. Therefore, the formula that already unfold has been captured and taken over by the technology. And we are the feeder to the technology, and mathematicians are the elder brother of the technology. Therefore today, what will be the phase of technology day after yesterday, tomorrow, day after next day, next week, will be decided by the contribution of today's mathematicians. Technology, it's not the complete solution. Technology is not the end of journey. Technology is just the beginning. Just the beginning. But the developments of technology will be depend on the mathematicians of today. If scientists, the mathematicians are at equilibrium states today, no further development of technology will be unfolded. Therefore, technology is not at the peak stage. It is just the beginning and many things to come in. And the pillar of technology is the mathematicians. Therefore today, as a mathematicians today, let us redesign ourselves to make the world a better for tomorrow. But today, the important thing is we should make this subject our students friendly. How we present? Suppose people's worry pretend about some animals. In our days, especially in Nagaland, I think in other parts of the world also, elephants-man conflict happens. In many places, many people has been killed by elephants. But whereas in many national parks, people are rushing to see the elephants also. Sometimes we feel, we see something, we look at different angles, look at it's an enemy. But if we want to fight the strong enemy, we should develop the formula to make friendship. We should design our minds that if we want to defeat somebody, the man opposition, the man enemy, we should make friends to learn his strength. As a mathematicians, we should understand the challenges. Why our students don't want to study math? It is our responsibility again to design the formula to understand what's the weakness in our students. But we always fail to do. But it's also important to design the formula to understand, to read the minds and the brains of our students. Then accordingly, we can react. And our students must make friends with this enemy if they think so. When you understand the weakness and the strength of your enemy, then you can defeat. Today, I think, as a teacher, as academicians, as expert, it is our responsibility to make our students understand the strength and the weaknesses, the problems of the mathematics, not the formula. The problem why our students feel problem of the problem of mathematics. But we should make aware and make it friendly to our students on mathematics. Because I, as an education minister of the state of Meghalaya, I want to tell today, I was tribal students. Tribal people hardly have patience for mathematics. I don't know exactly should I say, but exceptional. Most of the tribal students really have impatience for the mathematics. But there are many also. There are many also. But today, I think, in Meghalaya, we are shortage of good mathematics teacher. That is the reason today. There is a crisis of good mathematicians in the education sector of the state, maybe in the entire region also. But I'm also saying, not the degree, not the diploma to become the mathematics teacher, but it should be professional. It should be really mathematicians, not the degree and the diploma that the world is looking for, the students is looking for. When we teach our students, make sure students live with excitement and love for the mathematics. It's a responsibility of our teacher. It is not the curriculum that makes the students difference. It is not the system. As a Christian perspective, if we speak, it is not the church building that will make you a good worshipper. It is not the mandir, it is not the building that make you a good worshipper of God. But it is the pastor, the father, the fundit who pray, who bless us. What to make things difference. It is not the mathematics. It's not the textbook that make students difficult, but it's the teacher who are making them difficult. Therefore today, I would like to request all the research scholars, the academicians, or the expert today to dissect the problem of the mathematics and make it easy to our students. Today, moving up all the challenges, I would also like to thank our Professor Rajput and the entire NCERT team. Government, Meghalaya government has taken decision to adopt for adaptation of the NCERT textbook from next academic session. Knowing the challenges of the future problems in the country and the future of our students. We want our students from the state at par with the rest of the country and the rest of the world. And it's important. It doesn't mean only the first bench students will perform the best in the academic career. No. There are many students who are sitting at the back bench who do excellently well. Therefore today, let every corner of the country, the best brain come out to serve the country and to make the country proud. We feel why Indian sports is not to the standard that the world is going to, especially in football. Because we have not reached out to every nook and corner, and we have failed to identify the talents that we have. Therefore, if we have the platform, at every state, I'm just for the illustration, if we have the platform to groom, to identify the talents of our students, about talents as sports person, India might have lifting the World Cup, football World Cup one day. But we have not reached out to the every nook and corner to identify the talents. So today, if our state also, if entire country have the equal quality standard of education, then we will get the potential, the students, the right students that will be staying in the last bench of the nook at the corner of the classroom. With this objective, we have decided the Megalayans also. What the curriculum, the standard of our students, what you call the studies, the contents should be at par with the rest of the country. Therefore today, we want to see our students performing well, excellently well. Having said so, and a new education policy government of India has introduced, the only reason is to make India the global powerhouse in the world. India impacting the world economy. India present significantly at the world, at the global stage today. And new education policy is something that is shaking the world today. And it is really that I'm truly excited to see that new education policy will really make India difference in the eyes of the global stage. But there are lots of challenges. As we implement the new education policy, there is always challenges. There is always equal and opposite reaction too. Therefore, my friends, in this challenging technology time, it is very important to us to understand the challenges, the problems of our country should also take along. Therefore, if India wants to be a global superpower in economy, in in a defense, in technology, in different sector, sometimes we fail to understand. It is not the Prime Minister, it is not the policy, it's not the army chief, it is not anybody who make the things different. But if India really wants to become a global superpower, the education scenario, education sector in the country is they should be the first one to make things difference. And because when the education system is at the final stage, this is industry where India is going to produce a best industrialist, best army, the best doctor, best engineer, best sports person. It is not something else, but it is the only education sector that is going to make India difference. Therefore today at this very outset, as I said, I am pleased to join with all of you, and it's my really pleasure. I'm very happy, and it's very difficult to mathematicians come politicians. We need lots of formula, ideas, and the patient. And therefore, I believe in the days to come, the future of our country will be rest upon our soldier. And the future of our nation will be based, will be soldier on our responsibility of our commitment, of our contribution towards the growth of education sector. And mathematicians, it is nothing to say. We are the important pillar of the sector. If the country future will be decided directly proportional to the number of mathematicians, not inversely. So how much the mathematicians number increase, that much the Indian policy will increase. How much the mathematician formula increase, that much the Indians defense sector, Indians economy will increase. Therefore today, I am extremely to be the part of this wonderful and a very successful function. Thanks to Madam and all dignitaries that have come over here. And please be free, be happy to be here. If any problems, you can intimate to the government also. We will be happy to help over you. And those who come for the first time to this Shillong, don't miss to visit all the important places of Shillong. Otherwise, you will regret. Because you have come down to the wettest place on the earth. And please put your foot on the wettest place on the earth. Thank you so much, Madam, for this wonderful opportunity. I wish this conference a very wonderful and successful. Thank you so much, Matala Jai Hind.
Kubla sir. Okay. Yeah. Such beautiful lectures today, isn't it? Really, it is a day for the mathematics people. Sir has so beautifully drawn the connection between the mathematicians and politicians in the beginning. And how much mathematics the politicians need to do, we understand, and Sir has very nicely brought out the mathematics behind every politicians, and he has appealed to all the mathematicians out here to join politics so that you can make change in the society. A very important message from what I could understand from his lecture over here, that what he said is a very big concern for everyone, that the phobia in mathematics. And he has very rightly said that mathematics has not failed our students, but the teachers has failed in mathematics. The teachers need to redesign, what he said, has to formulate some formula to understand the minds and brains of the students, to design some formulas to make mathematics easier and so that everyone can learn mathematics with a lot of enthusiasm. So that was a very important message that he has given, and he has also wished to see that when teachers make a change in their teaching strategy in the classroom, he wants to see, or he wishes to see, thousands of more Ramanujan flourishing in this country. And that will perhaps make a big change in the society, in the educational scenario of the country too. The other thing that he also has mentioned about the formula, that the mathematicians are the elder brother of technology, and technology is just the beginning, and development of technology only will be dependent on the mathematicians. So with this, I think he has bestowed a responsibility on each one of you present here to relentlessly work for mathematics and make it a student-friendly discipline. The last point, that so many things he has touched upon, but a few things which has touched my mind is that what he said at the end also, if India wants to be a global superpower, then the educational scenario of the country needs to be changed. It is something which, if we want to really utilize our human resource, then this is the sector which needs to be looked into. And also, he has shown his confidence on the new education policy, which is going to bring about so much of changes, bring changes in the education system of the country. So thank you so much, sir, for being here with us and inspiring each mathematician present in this auditorium to work relentlessly and make the scenario of mathematics education better in the country. Thank you. As we draw close to the inaugural session, may I now request Madam B. Devi, Head DSM NERIE and the convener of the National Conference on Mathematics Education, to offer the formal vote of thanks.
Thank you, Dr. Tulika. Honorable Minister of Education, Government of Meghalaya, the chief guest of today's function, Professor Manjul Bhargav, the keynote speaker of the session who joined online, and then Professor G. Ravindra Sir, the former director of NCERT, Professor F.G. Dakhar, IC Principal NERIE, and Professor Anup Rajput Sir, DSM and NERIE-NCERT, and the respected faculty members from other RIEs, and the faculty members of NERIE and the non-teaching staffs, and the paper presenters of the National Conference. It is my privilege to propose the formal vote of thanks of this inaugural session. First of all, on my behalf and on the behalf of NERIE-NCERT, I extend my deep sense of gratitude to the chief guest of today for kindly accepting our invitation and making his gracious presence here in the inaugural session, and also for addressing the August House on the importance of good mathematician, prepared teachers who knows the strength and weaknesses of students, offer the good curriculum and the textbooks and the policies for making real understanding in the learning of mathematics in our country. Thank you, sir. I would like to place my heartfelt thanks to Professor Manjul Bhargav, worldwide renowned mathematician and the keynote speaker of today's event, for sparing few minutes from his busy schedule and deliver the address virtually. So you have very nicely explained the importance of teaching learning of mathematics, and we have to make the students free from the scary of mathematics, because many people are scared about the mathematics. But so you have very rightly pointed out that the way we taught mathematics matters a lot. And we should not teach mathematics in a mechanical way, and we should make it enjoyable, and we should think about the activity-oriented and the discussion-based teaching method. And we have to think about the exploratory method also. We should allow the students to discover themselves, to deduce something, and to explore, and after that they should understand that. So how to make these changes regarding this, he at present involving in the making of our curriculum and the textbooks in the NCERT at present. So, and he also said that mathematics teaching should be connected with all the subjects, especially for because he said many, the historical aspects of mathematics also. So Sir has rightly pointed out that it should be from the linguistics and the other subjects also. We should try to teach mathematics that way. That means that's why it's coming interdisciplinary approach. Thank you, sir, for the very meaningful keynote address. And I would like to place my heartfelt thanks to G. Rabindra sir also, the former director, for his presence in the inaugural session and his message that mathematics is a number and the number exists everywhere. There is no place where number doesn't exist. So this is very much with our daily life. And I also convey my heartfelt thanks to Professor Anup Rajput for his presence, physical presence here, and sharing the introduction to the keynote speaker of today, Professor Manjul Bhargav. Thank you, sir. Then my thanks goes to Professor F.G. Dakhar, IC principal, for her untiring effort, which she made throughout for this event to happen. Thank you, madam. Then I extend my thanks to all the paper presenters who came from different places of the country to make the conference successful, and my thanks also goes to all the faculty members who came from other RIEs. And if I have not mentioned anyone, if I miss out also, my thanks goes to everyone. And so, thank you.
Thank you, madam, for offering the formal vote of thanks. I would like to join madam as co-convener of this conference to thank a few more people. A big thank you goes to each of the advisory board member who has tirelessly worked for this conference constantly to make it successful here. Across the country they were, and I disturbed them all the time for all kind of advices. And special mention probably goes, maximum disturbance was done to Dr. B. Madhu, and so I think he has contributed a lot to make this conference successful here. Also Professor Anup Rajput, who has made it possible for bringing Professor Manjul Bhargav at least online, if he wanted to be present here offline, but then he could not make it because of his engagement with the ministry. And so nonetheless, he has joined us, so I thank sir also for this. And the most important part, and I think the strength of us is making this event successful, is the faculty members who has worked behind the screen for the success of this program. For different committees that are there, they have worked tirelessly to make this event successful. All the faculty members of NERIE in different ways they have. Our student volunteers who have worked tirelessly, the non-teaching staff who has run around for the different things to happen, to see it happening. And the most important strength is my studio and the ICT staff who have been running around for every small thing. So they are the main pillars which has made this event successful. Thank you so much, everyone, for making this event a successful one.